Yeah, thanks for always invite. And today I'm going to share a little bit on the progress on sort of the new stuff we are proposing at AltLayer. It's sort of the one of our new features for this real-estate rollup. And actually, we are going to launch a mainnet very soon, probably this or next week for this one. As we all know, right, as Patrick just mentioned, right now, we've already had like sort of a bunch of rollups like Optimism, Arbitrum, Coinbase Base, and Polygon, ZK EVM. And for the past 2 years, this space has moved so fast, and we already have a lot of mature rollup stacks. For example, OP Stack, Arbitrum Orbit, Polygon CDK, and ZK Sync ZK Stack. So right now, with all various providers like us, we can quickly launch rollups like within a few minutes. So basically, as you can see, right, after the years and years of work with all different projects and researchers, now we really have this kind of new era that sort of rollups as the new smart contracts. So based on that, right, apart from the general purpose rollups like OP, Arbitrum, Polygon, ZK EVM, right now we are also having more and more application-specific rollups like these game, social, DeFi, AI, DePIN, and all different rollups. And we believe that by the end of this year, probably we will have like thousands of rollups launched either by the project itself or by the providers like us. And once we have these rollups, right, like Patrick mentioned, there's a lot of issues, especially security issues around these rollups. So in that case, we really need to address this issue. For example, the single sequencer, and also sometimes for bridging services, right? We want better security on top of this fraud proof or ZK proof, and sometimes we want a more decentralized network to ensure the security for this bridging, or sometimes for the faster withdrawal. And on our side, right, just a quick like sort of overview for the talk. So basically, we are leveraging EigenLayer's risk-taking features and also shared security to basically launch a bunch of services to make all the rollup systems more decentralized and more secure. Basically, these services are either for providing better decentralization on the verification part, basically running a dedicated network with all the operators from this EigenLayer ecosystem. And then they will do the extra verification for the blocks and the transactions proposed by the sequencer. Or, as I mentioned later about this MACH, on top of the decentralized verification system, we can build a lot of new features. For example, for bridging or for some DeFi protocols, they want faster finality. So by leveraging MACH, they can achieve it. And along that way, right, we also have a decentralized sequencing to further decentralize the single sequencer into multiple like sort of nodes or validators to do all the verification and the block proposing. And we all know, right, if we are thinking about like the underlying settlement for all the rollups, for probably 99% of rollups, it's still Ethereum. When we talk about this settlement layer, typically we are seeing that, okay, this settlement layer should do the verification of the proofs, either this fraud proof from this optimistic rollup or the ZK proof from the ZK rollup. And beyond that, one interesting part is something like Patrick mentioned, right? It's a bridge system between the L1 and L2. Since we have the proof system, we can really have the native and secure bridge between these two like, sort of layers. And natively, we can enjoy the liquidity from the L1, like Ethereum, to the L2. And beyond that, right, we can also build various like, sort of messaging protocols across different rollups. That's something proposed by this Optimism superchain, and at the same time also this AltLayer from this Polygon CDK project. And once we know a settlement layer, right, as a rollup, we need to submit the proof to the L1. Sometimes we also need to submit the sort of data to Ethereum. And we want to know when, as a user, right, when we can finalize, or we can say, okay, my transaction on the L2 is finalized on this rollup, or alternately on L1. So in that case, if I do some transfer of my tokens or bridge of my tokens, and then I can feel that, okay, it's safe now, instead of like transfer and the counterparty doesn't receive it, and later I don't know how to like really verify that. So that's sort of the notion of finality. Typically, we need to make sure once in the transaction, the block can be finalized on the L2. At the same time, it should be settled on the L1. And once we go deep into this concept, right, we need to look at what's the current finality on Ethereum. So a little bit different from this pre-POS sort of upgrade. Previously, we all know that Ethereum is a proof of work system, right? But after this post upgrade, right now, Ethereum is completely different regarding the consensus protocol. And if you look at the current finality definition of Ethereum, as you can see, right now Ethereum has the epochs and slots. For each epoch, we have 32 slots, and each slot is around like 12 seconds. Actually, for each slot, typically is a normal Ethereum block. And when we say we get the block is finalized on Ethereum, actually, it's not that straightforward. It's not like, okay, after one slot, after one sort of block, 12 seconds, it's finalized. Actually, it's a little bit complicated. If you look at this diagram, right, or this picture, so basically, once a block is proposed to Ethereum, we need over 2/3 of the validators. Right now, we probably have around like 900,000 validators on Ethereum. We need like 2/3 of them selected to attest this block into this justified epoch or justified phase. And after that, right, we also need, we further need that sort of the 2/3 of the state ETH to basically ensure that, okay, this block, we are okay with it, and after that, this block will be finalized. And then in that case, if you can see, right, once we send transaction is included into the block, but actually we need to wait for another 2 epochs and to make sure the block is finalized. So that's sort of like already, that already takes us over 12 minutes because as we know, right, one epoch, 32 slots, and one slot is 12 seconds. So in that case, right, even on the L2 side, we generate like sort of a block of for the aggregated transactions, probably within 2 seconds or sometimes a sub-second. But we need to post the state rule hash or sometimes some updates to Ethereum, right? Then that transaction need to be included into the block, and that block need to be finalized by the Ethereum validators. So if we send a transaction on the L2, typically the finality actually depends on this 12 minutes time for this Ethereum finality. So in that case, right, as I just mentioned, it's not as straightforward. We say that, okay, on OP Arbitrum right now, they can reprocess transaction very fast within 2 seconds, but can we trust like sort of this kind of block of finality or soft finality on the L2? For some of us, probably it's fine, right? We are doing this social gaming, but for some of us, we are building this DeFi protocol or bridge or running some exchange, right? So in that case, we want a hard finality. So basically, we want this state rule hash to be submitted to the Ethereum and this block to be finalized. Yeah, as you can see, right? So depending on the different types of applications, we really have different requirements on the finality. Some of the application we are fine with the soft confirmation on the L2 based on the single sequencer, but some of us probably not like sort of satisfied with this kind of soft finality. And then back to the topic, right? What we are proposing basically is an alternative way for users to have both like sort of this fast finality at the same time a very decent security guarantee on the sort of the transaction confirmation on the L2. If we really look at this hard finality and highest security, right? We definitely need to wait for the final finality on Ethereum. But at the same time, we can leverage like EigenLayer, this shared security, to basically borrow this economic bonds or economic security to ensure like sort of some of the operators and basically to have this like faster finality. And back to the topic, right? For MACH, in brief, like summary, basically we organize a decentralized network with all different operators and validators to redo this kind of execution and also some state transition functions to make sure the transactions or blocks produced by the sequencer are correct. And this layer is sort of built on top of EigenLayer as an AVS. So the good thing, as you can see, right? So basically, we decentralize the verification part for the rollup because right now for all the rollup stack, either OP, Arbitrum, or like even this Polygon CDK, they are single sequencer, and for ZK proof, we all know that it is a single prover. So in that case, it's quite centralized. For big brands, it's fun. OP, Arbitrum, Base, we know they are having big backers, so they won't run away. But for some new projects that are like this application rollup, right? And basically, we don't know their name previously. Even they have the sort of the proof, either fraud proof or ZK proof, but still it's sort of a single sequencer and single verifier or prover. So in that case, it would be great like we can run a decentralized network. Of course, we can say we run that L1 or basically with all the different validator with new issue tokens. However, it would be great like we can quickly bootstrap the network with existing and stable assets like Ethereum. So that's why we like basically collaborate with EigenLayer to build this system. And one like sort of basic design is something as I mentioned, right? We have a decentralized network and just perform all the verification work for the L2 blocks and the transactions, and then we post this confirmation to the L1. However, there's a bunch of other ways we can improve the performance or efficiency, as Vitaly mentioned, right, for this faster finality layer. That's why, apart from proposing this prismatic mode, basically you need to re-verify everything like a full node. We also have this optimistic mode and also validity proof mode. Yeah. So as I just mentioned, right, one way that we have a group of nodes to do all the verification as full nodes, and on the other side, we can also do it a light way. So this is the optimistic basic mode. We develop like these light clients. Actually, it's a stateless clients. Basically, run the software by all the operators to regenerate the proof. And it only trigger this kind of proof verification when there's something wrong happen. For example, a sequencer becomes malicious, and it does some double spin attack. So in that case, the network will detect this issue and generate the ZK proof and post it to the L1 for the basically the L1 can do the verification and basically slash the stake for the counterparty. And beyond that, apart from this fraud proof, this bisection protocol, we can also directly do this bisection protocol. After that, we generate ZK proof for a single instruction. And in that case, the L1's verification cost will be super low. And beyond that, we, as I mentioned, right, we have all different protocols and use cases like exchanges, DeFi protocol, and bridges. So for them, they really want to get this proof and also has a security guarantee. So in that case, we can generate all the ZK proof, not just in an optimistic way. It can generate based on the requirement, for example, every few seconds. So in that case, we can always see once the result generated from this decentralized network, right? They can do the verification on Ethereum and make sure like, okay, the proof is correct, and we can really trust this decentralized network on this verification of the single sequencer. And based on that, right, as I just mentioned, apart from this like L1's hard finality for like over 12 minutes, all these L2s like sub-second sequencing time. We can also have this sweet spot as MACH, basically running a decentralized network with economic security guarantee. And by the same time, we can provide faster finality layer within a few seconds for all the users, developers, and different DeFi protocols to use. So in that case, they don't need to wait for this long, like sort of finality time from this Ethereum. And yeah, we believe like this will be some very crucial component for a lot of DeFi protocols for the rollups. And we are pushing a bunch of new projects using this kind of new protocol. And we will see them very soon, probably this or next week. Yeah, that's all the presentation. And thanks for your time. I hope you enjoy the event. Thank you.